Okay, so I'm sorry these took me so long to get up. I have a million things I am trying to get done, just like you all. And I need to readjust that a little bit. Maybe pull it up so I can have more paper. Okay, there we go. So the problems we were going to work Monday in class, I'm actually going to make you guys some videos, and they're going to be quick. I'm not going to explain a whole lot. I'm just going to get through. So example number 4, you guys can pull up your documents, and it is the exam number 2 review, and the notes are in your, well, I'll just try to post, well, they're in your week 11. Okay, the solutions are also there. Anyways, so let's get started. So number 4, we have draw a free body diagram, calculate support reactions for the beam. A is fixed. So our free body diagram, okay, if we're drawing a free body diagram, should look like that. And then I'm going to go ahead and segment it so that I have 4 feet, 8 feet, 4 feet. And I'm going to see at the end I have this axial load of 2,000 pounds, and it is 3 feet up. And I also have this axial load of 1,200 pounds. So that is creating a moment there at the end. Plus we have axial force. I have 2,500 pounds down here. And then I have a triangular load, which again, I'm just going to dot in. And I am going to go ahead and tell you that the area is 1/2 base times height. So I have 1/2 base times height. And let me find my calculator. So we get 0.5 enter 8 times 2,000 times, and I get 80,000 for my vertical force, which seems very, very large. So I'm going to recalculate that because that doesn't seem anywhere close to correct. So 0.8, 8 times 2,000 times, nope, 8,000. I think I said it was 80,000. I misread it. So 80,000 pounds. So I'm going to put that right here. I know it goes through the large end of the triangle. So that's going to be a 1/3 and a 2/3. And that looks like everything except my reaction. And at my wall, since it's fixed, I could have AX, I could have AY, and I could have a moment at A. I'm using right-hand rule and assuming everything positive to the left and up. So now we can start. Let's sum forces in the X direction. Come across here, I have AX, coming across, minus 2,000 pounds, doop, plus 1,200 pounds. Got to the end of the beam. I know all of those have to equal 0, so we get AX equals 2,000 minus 1,200. AX equals 800 pounds, positive value, so indeed to the right. Okay, now we can sum forces in the y direction. Has to equal 0. Start at the left. Positive is up, so I have an AY minus an 8,000 pounds minus a 2,500 pounds. That's all I have in the y direction, so that equals 0. AY equals 8,000 plus 2,500, so AY equals 8, 9, 10. 10,500 pounds. Got a positive value, so it is indeed up. Oh, you guys can't see that very well, can you? Let's see if I can adjust here on my desk so that you guys can get an idea of what it is that I'm doing. Okay, so now you guys look at your free body diagram. We are going to sum moments about A, and I'm going to start at the left and move to the right, and we can see that at A, I am assuming a positive moment. Okay, by behavior, it also happens to be positive with right-hand rule. AX and AY don't cause a moment at that point. The distance is 0, so let's head across the beam. So I have minus 8,000 times 4 feet plus, it's going to be 1/3 of 8, so 8 feet times 1/3 over, minus 2,500 pounds. times 12 feet. Sorry about that. Plus 2,000 pounds times 3 feet plus 1,200 pounds times, I forgot to label that. Let me look back up at my picture because I didn't put it on my Freebody diagram. And it looks like it is 1 foot 6 inches. So we're going to call that 1.5 feet so that we're in consistent units of feet. So I'm going to have 1,200 times 1.5. So I think I have everything on there. All of this equals 0. So the moment at A is going to equal 8,000 times 4 plus 8/3 plus 2,500 times 12 minus 2,000 times 3 minus 1,200 times 1.5. And we should find that the moment of A equals, let me pull up my calculator. So I have 8,000, 4 enter, 8 enter, 3 divided by, plus, times 2,500 enter, 12 times 2,000, change sign enter, 3 times 1,200, change size enter, 1.5 times, plus, plus, plus. And I get 75,533 pound feet. I got a positive value, so I do indeed have counterclockwise rotation. And there's our final answer. Thank you.